you're confused and overwhelmed with AI, and I don't blame you. There's a lot of noise out there, and no one really knows what's important and what's not. There are new tools coming out every day. There are new frameworks, new ideas. All the companies are saying that their AI is going to replace developers and this and that, and everyone should be paying attention. My experience running a tech studio and speaking to a lot of founders and a lot of our clients is that nobody seems to understand what AI really is. And in this video, I'm going to take you through a workshop that we did for one of our clients last week to go from the very fundamentals of what's AI, what are LLMs, and everything in between, all the way to agents, so that by the end of the video, if you understand everything that we're going to cover today, and I'm going to do my best to not be unnecessarily technical, but if you understand everything that I'm going to explain now, you're going to be ahead of 99% of the people, because the industry, like the whole AI space, is full of noise and you don't really know what's going on. And the reality is that if you understand a few fundamental ideas, then you can, every time something new comes up, you'll be able to place it in the right bucket and you'll be able to build your own mental model to think things through. So I'm going to be running through this presentation on my iPad. It's all handwritten, it's not pretty, but it has all the value in here. We're going to be talking about AI fundamentals, but more specifically, we're going to be talking about generative AI and more specifically LLMs. LLMs and generative AI are not the only things that matter in AI. AI is very big. AI has a lot of other components. But when everyone's talking about AI nowadays, this is what they're talking about mainly. So we're going to cover this. And so what's the agenda? I'm going to explain what's an LLM. What's the simplest concept? That's the building block that started the entire thing. Then what's context in the context of LLMs? What's RAG, which was more popular last year, this year's agents, but it's a very good fundamental to have. Then what is the assistance of the responses API, which is a product that OpenAI released to build things with AI, and why are these things relevant? And then we'll cover what are structured outputs, and then we'll take all of that, and then we'll go talk about agents, what's an agent, and how to use an agent. Cool? Let's go. So, first concept. What are LLMs? LLMs 101, right? So literally all an LLM is a black box. It's a black box that takes text as an input and gives you text as an output. That's it. Like the entire AI revolution since the first GPT and the original ChatGPT and all that, like all of that is based on this simple idea. It may seem that there's a lot of technological advancements going on the past few years. It's not true. I've made a video on that, but it's not true. LLMs, like they've been the same pretty much for the past 3 years. So again, what's an LLM? It's a model, it's an AI model, it's a system. Think about it as a black box, something that you throw some text in and it gives you some text out. And that's trained with a lot of data and it's trained to look like a conversation, right? Like it will give you the most possible, from a statistical point of view, it's going to give you the most possible output. So let's say you have something like your input is going to be hello. Think about it as ChatGPT, right? So your input is hello. So what's the output? What's the most likely response on a conversation? Since they are trained to be like, they're trained on conversation data most of the time. So for hello, the most likely output is going to be hello, how can I help you, right? And so that's really it. And there are important implications on this. Like it doesn't remember when you're having a conversation. That's what we're going to cover in the next section about context. It's literally a function. If you're thinking from a math or developer point of view, it's a function. Like for any given input, you get the most likely output. Now, it's not always going to be the same because it's statistics, but that's that. Simple as that. Hopefully this is clear. And so obviously you also have what's called a multimodal LLM, which is they don't take text as input. They will take text or images or audios and then output text. And that's different from having something that converts your audio through speech to text into text and then gets you text out, right? So there are more things to this, but most of the agents and most of the stuff that we are going to be covering, they are text-to-text LLMs anyway. So if you understand this concept, you're very good. Cool? All right. So now that we understand LLMs, let's talk about context or how to have a conversation with an AI. So as I said, LLMs don't remember. Like there's a problem. For the same input, you'll always have the same output. When you speak to ChatGPT, it does remember. It remembers your entire conversation. That's built on top of an LLM. That's not the LLM, right? And so, again, think about it. Text in, text out, nothing else. How do we make it look like it can remember the conversation? Well, all we need to do is transform everything that we're doing into something that looks like text in, text out, right? So the solution to that is we need to give it more context, right? So it's going to look like something like this. Imagine you have a conversation. Again, this diagram here, this represents a conversation, say, with ChatGPT, right? So human is your message. Again, think about the one said before. Hello, how can I help you? So, hello, how can I help you? And then let's say you say something else like, can you help me with this math problem, for example, right? Again, LLMs don't remember the conversation. So what we do is we turn the entire conversation, like all this, which is what we call the context, this is the entire text. So behind the scenes, what ChatGPT is really doing, ChatGPT, Claude, DeepSeek, all the chat models, what they're really doing is they are taking your entire context and saying, like, having like behind the scenes a prompt says, given this, given this, given this conversation, what's the most likely output, right? So ultimately, the LLM itself doesn't need to remember. It's onto us, it's onto the implementation to remember all this and then pass the entire context into the LLM, right? And I know what you might be thinking is like, but if I go to ChatGPT, I don't need to do that. Like you can just write. That's true. Again, an LLM is not ChatGPT. ChatGPT is the product. And passing all this, passing the entire context, adding this prompt at the beginning, all that, that's done by OpenAI. ChatGPT is a product. GPT 4.5 is the model, is the LLM. Hopefully you understand that difference, right? Cool. So now we can have a conversation. We have a new problem, right? What if the context gets too big? You might have heard that this LLM has this many tokens context window, this that Gemini's claim to have 1 million token context window, which is true. ChatGPT has around 100,000, right? You can think of tokens, they're roughly 3/4 of a word, right? We don't have to go into the details, but that's the limit of your context, right? Now, as you have a longer conversation, at some point, your entire conversation, like all this, is not going to fit. Is not going to fit anymore in your context, right? You can say, use all these conversation. The LLM is going to say, hey, like this is too big. I don't know how to deal with this big of an input, right? So what we need to do is, and this is what ChatGPT, Claude, all these models do behind the scenes, is, all right, imagine that we have this entire conversation, right? So what they're going to do is say, okay, I'm going to take the beginning of the conversation. Again, this would be way longer, but I'm going to take all this and I'm going to summarize it. right? And so your summary plus the latest messages, now this becomes the new context, which is what you would then pass on to the LLM, right? So hopefully you understand these concepts. Like the earlier parts of the conversation, what we are doing is we just squeeze them into a summary, right? Which is why, as you have a longer conversation with ChatGPT, I'm going to continue using ChatGPT as an example, but again, think ChatGPT, Gemini, Claude, any chat, right? Um, the things that you said at the very beginning, they get squeezed because they get summarized, right, over time. And so that's why it's important to understand how these contexts work, because the LLM ultimately, and that's why we talk about LLMs at the beginning, like this thing, like this with the summary, not everything else, with the summary is what's going to get passed. Like the LLM doesn't have access to all this, right? And so this is going to become very important when we talk about agents, when we discuss coding agents, RAG, etc. Because this limitation and this idea that the LLMs don't remember, you need to engineer a solution around the LLM to remember. This is the core idea. And just as an aside, when you've like literally all the improvements that have been going on for the past 3 years that feels like progress, they're not really progress in the AI necessarily. Yeah, models are getting better, but they're not necessarily improvements in the AI thing necessarily. They're engineering solutions, they're products, they're wrappers around this problem. Cool. So hopefully this makes sense. Let's move on to RAG. All right. So again, we have now a new problem, right? We want the LLM to have access to a lot of knowledge that we can't really pass on to that context. Think about, let's use the quintessential example for RAG, which is like a lawyer RAG, right? You can't put in your context all the law, like all the laws, all the books, all the everything. Or if we are talking about your business, like you can't fit everything in your context. We typically have around 100,000 tokens. That's a lot of words, but that's, I'm looking, however long it is not enough to typically put all your knowledge in there, right? And so, well, what's the solution? Well, we're going to find a way to grab the relevant pieces of our context. And when we ask a query, like when you ask a lawyer, like, hey, if I did this, am I going to jail? Right? He doesn't need to know all the law. He just needs to understand the specific log that will say, yes, you go to jail. No, you don't. Right? So what's the solution to having a lot more knowledge? This represents all of our knowledge, a lot more knowledge that we can really manage, right? And solution is add the relevant pieces to our prompt. So again, let's say we have this chat history, right? And you ask, let's run this lawyer example. Like, hey, how can I help you? Am I going to jail because I did this bad thing, right? And so what the AI is going to do, so not the AI, but what a RAG implementation is going to do is, okay, is there anything in our knowledge that's going to be relevant here, right? In that example that we gave, like, I did this, am I going to jail, right? So I did this, we are going to go search in our knowledge, like things for this, like I was speeding in the highway, right? From all the knowledge, all the laws, all everything, like what is relevant to speeding on a highway, right? Try to grab that. Like, is anything in our knowledge relevant? Say no, we just don't do anything. We say yes. Oh, we found the law. We found the 3 paragraphs that talk about speeding on highways, right? What do? We enhance the prompt, and behind the scenes, and again, this is what's going on when you use ChatGPT, for example. You throw a file there. It's like, okay, I'm going to change the prompt behind the scenes. You won't notice that, but I'm going to change it to like, I did this, like the enhanced prompt is going to look like, given this user message and obviously all the context as we talked before, and this additional piece of information that I found, give me the answer, right? And so we are enhancing the prompt of the human with the context that we've grabbed with the RAG, right? And eventually we end up with something like this, which again, we go back to the topic we've been discussing. We need to pass this new context to the LLM. The LLM doesn't have access to the rest of the knowledge, just has access to the conversation and then the human question and the context, right? And then we get the answer and we continue forward. So as you can see, the key idea of RAG is we get what's relevant, we add it to the context. That's why RAG is called retrieval augmented generation. We retrieve what's important, we augment the prompt, and then we generate the answer. That's it. Cool. So this is RAG, and now at this point you should understand what LLMs are. The fact that they don't remember, I'm going to keep coming back to this idea because this is the cornerstone, this is the fundamental idea in generative AI. AI doesn't remember, it's just input output. Then we can manufacture a context that we pass so it looks like a conversation. We summarize that, and sometimes we might have a knowledge base that we retrieve information into, and we add that to our prompt, right? Cool. Now, at this point, we have all the building blocks that build ChatGPT, Claude, like Gemini, like all these chatbots. That's what you have. And if you go to any like lawyer GPT or whatever the case may be, this is all going on. And all the AI wrappers are just fancy ways around doing this, right? Cool. Then what are the assistants or the response API? Again, if you've worked with the OpenAI API, you might have come across these tools. If you don't and you're working with APIs, I strongly recommend you take a look. I'm going to cover what they do, but what they are is, as I said, like building the context, building the RAG, all that. Those are things that we need to engineer around the model. When you have access to the GPT 4.5 API or the Claude or the DeepSeek API, they give you the LLM, they don't give you all the building blocks, right? Taking care of the conversation history and summarizing the previous messages, doing RAG, all that. Those are simple concepts to explain. They're actually quite challenging technically. And so OpenAI solution, which OpenAI is the company that has been the most prominent at not only building good AI, but also building good tooling around AI. All the other companies, Anthropic and like Gemini, they're catching up. But OpenAI has been really good at this, right? So what are the assistants API? I'm not going to go into a lot of detail here. You can check it out, but at a high level, right? What they do is they give you the ability to create an assistant, which is, all right, instead of having access to the LLM directly, you create a thread and you post messages to that thread, and then you get responses. And you can also give it like a system prompt that modifies how it behaves, right? And you can also attach a knowledge base. So by doing that, by having the concept of a thread instead of the LLM, now what they're giving you is they're giving you all the context management, all the summarization, everything for free. You don't need to think about how to do that. And you can also create like vector stores, knowledge bases. For all intents and purposes, they are the same thing. And you don't have to think about that, right? So again, the concept is the thread. Now, what are the responses API, which is their newer version? It's supposed to be way more flexible. Instead of giving you a thread, what they do is, and bear with me with this octopus looking diagram here. It's like you have a human message and a response, and then instead of having a thread, you post another message, but you can say, hey, this is a response to this previous one, right? So you link it to the previous one. And so you can see that if you stack things on top of each other, you can eventually create a thread, right? And you can also attach a knowledge base to it. Cool. So yeah, both the assistance and responses API, they were OpenAI's solution to say to software developers, like, hey, like we build the AI, but we also understand that managing context and managing RAG is a tricky part. So we're also going to give you that for free, right? You can do that so long as you build on our platform. And obviously this is like, from a business point of view, they do that because they want you to keep closer, because then you only use their models. Like these tools, these services, they only work with OpenAI models, right? So that's the assistance and the response API. Now the assistance is getting deprecated. This was very popular last year and it's going to continue being this year in favor of the responses. This looks a lot more complex, but when we talk about agents, you'll realize why this, like the key part of this is a lot more flexible to build other types of things, right? So moving forward, if you've never worked with the Assistance API, don't start, because they're going to deprecate that in a year, and start really with the responses, because that's their future-proof, their future-proof solution. Cool. So now that these are two examples, cool. So now we should have full understanding of how the underlying technologies work, how the LLMs work, context, RAG, and solutions that are implemented on top of that. Also for what it's worth. Like, as I said, ChatGPT, Cloud, and all that. Also solutions to the engineering solutions to use the technology in a way that's useful for the user, right? Cool. So now with that, let's talk about structure outputs very quickly, and then let's talk about agents, right? Structure outputs. As we've been saying, LLMs, the way they work is they get text in and they give you text out, right? Now, do you think of text as just like normal English language, any language, right? Just a paragraph or whatever the case may be. There's another type of text that they can output that's called JSON. And if you're a developer, if you have any background in software engineering, just skip this part. If you're not, bear with me. I'm going to make it very simple. What's JSON? JSON stands for JavaScript Object Notation. And what it is a way to basically organize text in a structured manner. It's very simple, can contain text, numbers, or booleans, which are just true or false values. And they can have objects and arrays. So an object is like a dictionary, like you have an entry and then you have some description about it. And then arrays is just lists, right? So I'll give you an example in a second. What's this? So let's say we have this normal text. That's an answer from ChatGPT. This is not a good one, but I just asked ChatGPT, hey, give me a ICP, if you're familiar with the marketing term. It's like a description of a client profile, right? A fictitious one. And so it gives me this paragraph, right? Which is very understandable for a human reader, but that's not very friendly to interact with other parts of code or machines, right? Like this is just a big paragraph. Then I asked ChatGPT, hey, give me the JSON version of this, right? What's the JSON version? Something like that. As you can see, we have like, again, ignore the curly things and all things that are scary if you're not a developer, but you basically have like, okay, an ICP, we have like demographics, age range, location, like what is the nice thing about this compared to something like this, and this will bleed into when we talk about agents. Um, this is very reliable, right? If we always know that our ICP is going to have like these different parts, we can then have an agent. We can then have a piece of software that takes this, like this age range, and say, okay, I know in the ICP where the age range is going to be. What are the motivations, right? So you can grab the specific parts of the result without having to understand the entire result all the time. And this becomes more and more important as you build more and more complex structures. So this is a key building block, and you can do that. You can force the AI to give you JSON. Now, you can say, just give me any JSON, which is what I did here. But what you can do is you can force your AI, you can force your LLM to say, give me a JSON of specific shape. And when I say shapes, like what are the fields that are going to be required, and where and which order, right? That's what we call a JSON schema. So this here, again, if you're not technical, just understand the concept of this. This JSON schema basically says how to generate this, right? It says, if we take a quick look, it's like, what are the properties? Well, we're going to have like a big one that's going to be a customer, an ICP, an ideal customer profile. It's going to be an object. It's going to have properties. So you can nest these JSON structures, right? It's going to have type object and then age range. It's going to be a type string. You can see here. It's going to have a location, which is going to be an array. It's going to be a list of things. And then you have them here, etc., right? So all this is defined, all this defining how this goes. So let's say you're building some sort of marketing agent for anything that you do. When you're working with the API, you can go ahead and you can say, all right, I want the ICP to look like this. And now you can get something very structured that then you can use when you need, right? So hopefully this explains what a structure output or JSON is. Again, just summarize, why would we want to use this? Well, it's very structured, and so other pieces of software can understand this very well. You can say your particular piece of information, for example, the age, like where exactly in that piece of text is, you don't know with a paragraph, right? Second, again, very predictable. And if you use a JSON schema, it's exactly what you want. And then, well, this is what allows tool calls. Like when the AI is going to interact with something that's not an AI, that's like traditional software, you need JSON, because traditional software doesn't understand normal text, right? So that is structured outputs. And so with this and everything that we talked about before, let's talk about agents. What are agents? Everyone's talking about agents, agentic architecture. Agents are the future. Agents are going to blah, 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 blah. Agents are very simple, okay? Like, as we've discussed before, AI, like it's simply a text prediction thing. You have some text, you get the most relevant text, and it simulates human thinking, right? That's that. It gives you information. Before, when ChatGPT initially came out, you would ask him like, hey, like what should I do with this piece of code, for example? And they tell you what to do, and you'll go do it. Agent comes from agency. Like an agent, it's because it has agency, which is it's the ability to act. Like that's the definition of agency, right? Before the agent, again, using the example of the ICP in marketing, right? Give me an ICP. Gives you that. You, as the user, you'll go save that to a document, then update this, that. You'll go do it yourself. What's the agent? It's exactly the same, except these actions can be performed by the agent, which is also why you need the structure outputs to build an agent, right? The agent is just an LLM that has the ability to perform the actions it decides. End of the story. There's nothing more complicated than that. If someone is trying to tell you that agents are more magical, they're not. They're not. You can obviously assemble this in a very complex manner, but the fundamentals are very simple, right? And so how does this work? Well, it uses what we call tools. And what's a tool? Is just something that they can use to perform the actions. So again, traditional software, this would be what we call like APIs functions. So that can be a tool that the agent can use. So if we take the simplest example of what an agent could be, it's like a weather agent, right? Say, what's the weather in New York? So you'll give it some tool that's an API that can check the actual weather. And so the AI, instead of trying to figure out what the weather is, again, they don't know anything because they are just like a text prediction thing. They'll say, okay, instead of trying to come up with it, I also have access to this tool. So I'm going to generate the JSON that calls this tool, get the answer, send it back to the user. That's the agent, right? So effectively, what an agent is going to be is you have some input, you have some LLM, and then the output can either be using a tool, like do we need to check something? If yes, use the tool, and it passes back to the LLM. And again, this is using the conversation architecture that we discussed before. The LLM doesn't remember, so context is still very important for agents, but it's going to perform this cycle. Before agents, you wouldn't have a feedback loop of any sort because the output would be do this, and this part here would be the human. Now we don't need the human anymore, so it enables the agent to run for longer before you need some sort of human intervention, right? So again, the key idea that I want you to take from this is an agent is simply an LLM that can act on its own suggestion, evaluate the result, and prompt itself. That's the missing part for that feedback loop. If you know anything about feedback loops, it's what you need for something to run by itself. Like otherwise, it will do something and stop. The agent will evaluate. Now at some point, it's going to say, hey, I need a human, or hey, I'm done. But it enables the AI to run for longer, right? And do things. Hopefully this is clear. We can go into a lot more detail. And obviously what this enables is a lot of things that can run independently, and you can connect agents to another agent. So an agent can be the tool that another agent calls in itself. So this enables many, many things, but the fundamental idea is simply this: an AI that can act on its own suggestion. Then when you say like, oh, I have these browser agents or these coding agents or blah, 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 those are specific implementations. Cursor, Lovable, Bolt, all these tools, all they do is you have your AI, and the thing is, when you go to ChatGPT and tell it, give me code for this, it will give you the code. Those coding agents will say, okay, this is the code. Now I have the ability to write into files on my computer to implement the thing that I said I should do. Do that, read the new file, say, okay, that makes sense, or it doesn't make sense. Let me go do changes, right? That's really the agent. And so what are the benefits of agents? Well, it removes human actions when they're not needed. Like sometimes they give you very simple stuff, like you could just do it right away. And so the agent can run for longer. So that's benefit number one. Benefit number two is now that things don't need a human to do like all the monkey tasks, like the agent can actually act now. So it allows us to build very complex cases by combining different agents and different tools. And that you have outrageous examples, like agents will run your company, like they won't, not anytime soon. And we'll talk about that in a second. But that's the potential of these things, right? The LLM is your reasoning logic, is your brain, but now they can act, and so they can act and then get a result that gets passed into another LLM that get a result. So you can build very complex use cases from this. Now, what's the risk? Well, the risk is you're trusting AI to be a leader, to be the decision maker. If you've used ChatGPT or if you've used any AI tools, you know that they're not that really good. Not yet. Like they can remember a lot of stuff. They're not really good at making very big decisions. So if you're building with agents, you will realize that the main problem is that they're kind of stupid, right? And it comes down to like how you manage context, which is what we talk about, how you manage RAG, etc. The AI, at the end of the day, doesn't remember anything. And you as a human, you have all the context that you need already in your brain, right? So this is the biggest risk. Now, what's the solution to this risk? Well, first, you need to start very small on what you're trying to do with your agents. Just if you tell like run my company, very complex use case. And second, you need to evaluate the results, right? Which again, those two things are easier said than done. I can make an entire video on that if you're interested. But hopefully this clarifies what an agent is. And so again, finally, like before agents, we had chat-based workflows, right? So you have a chat, and then the chat tells you to do this, like you're having an advisor, but you ultimately do things. Agents, they work by themselves. Like they don't need as much of your inputs. It goes from the AI tells you do this, you tell the AI, hey, I need this done, and the AI will perform some actions and come back to you with the result, right? And so this allows something like this. This is just a simple, like a high level architecture for like how would a marketing agent look like. So you'll have some ICP agent, like this would create your ICP. You'll create your position statement, and then you can maybe like allow it to scrape competitors' websites, right? And then you would have also like a review agent that will say, okay, this was doing well or not. These things grow in complexity, and you might have seen like all the N8N workflows and whatnot. Like that's what makes the workflows grow so much and look super fancy, because you actually need to have like small pieces. And as we said, you want to start small and you want to keep different agents small, right? But hopefully, if you understand this, like you will no longer be intimidated by all these N8N massive workflows. That's just small things, like it's this core idea implemented in many different ways. If you decompose it into the different pieces, it's actually very, very simple. Cool. So that is it. We've covered a lot. So that's it for this video. Again, I know it's very, very dense and we're already almost 40 minutes in. So I don't want this to be endless. There's a lot to cover. This became very dense. Watch it again. Go look into the topics that you don't understand. Ask me any questions in the comments. But as I said, if you understand all the concepts that I've mentioned that we've covered today, you'll be ahead of most people talking about AI, because almost everyone is talking about the uses of AI, which is very important. But that hype over the use cases, etc., is hiding the simplicity of the underlying technology. So again, hopefully this is useful to you, and I think that's it.